Hi, this is Scott. I really appreciate our sponsors because they make the show possible. Today's show is sponsored by Developer Express. Become a UI superhero with Dev Express controls and libraries. Deliver elegant .NET solutions that address customer needs today. By leveraging your existing knowledge, you can build next-generation touch-enabled solutions for tomorrow. You can download your free 30-day trial at dx.hanselminutes.com. That's dx.hanselminutes.com.
From hanselminutes.com, it's Hansel Minutes, a weekly discussion with web developer and technologist Scott Hanselman. This is Lawrence Ryan announcing show number 514. In this episode, Scott talks with Dana Lewis about the Open Artificial Pancreas System that she and her husband created.
Hi, this is Scott Hanselman. This is another episode of Hansel Minutes. Today I'm chatting with Dana Lewis, who along with her husband are a part of OpenAPS, an artificial pancreas system that is open source. And I think it's so great that here we are, two diabetics, and we're managing our blood sugar and our diabetes with technology.
Thanks for having me today.
No, it's absolutely my pleasure. So let me start. You're going to talk 90% of the podcast, but I wanted to just set a little bit of a level set for people who are listening. We are both type 1 diabetics, which means we don't make any insulin, as opposed to type 2 diabetics, or what used to be called adult onset. But for us, there's no amount of yoga or green tea or cinnamon. I mean, you've had people, I assume after this podcast, everyone is going to say, "Oh, I'm so sorry. I heard you're diabetic. Here, try some yoga and green tea." Like, that's not going to solve this for us, is it?
Right.
And that's no disrespect to our very well-meaning listeners who may want to give us some other system. What's different about our diabetes than the kind that maybe a little yoga and a little green tea could help with?
Well, the big difference is no insulin means that you have to check your blood sugar and then also give yourself insulin. And that could be through shots. That could be using an insulin pump. And it means constant measurement of everything, what you eat, when you exercise, and everything else that goes along with life.
Right. And when we say our pancreases don't do anything, this is why, green tea might give us other health benefits or yoga or whatever. These could all improve things, but it doesn't solve the underlying problem with our pancreas, which is it's not doing any work. So that's why we talk about artificial pancreases, right?
Exactly. And that's one of the confusions when we talk about artificial pancreas. We're not implanting an organ. We are not doing that. But what we are trying to do is replicate some of the same function, which is moderating the amount of insulin in response to the glucose in our body.
I see. So this isn't a perfect replication. It's not an implanted organ. It's not even 100% simulacrum of a pancreas. It's just doing the kind of, like, I've been diabetic 23 years. You've been diabetic how long?
14 years.
So many, many, many years you were doing these calculations yourself. You look at some food and you go, it looks like about this much insulin. You weigh it. There's all these different ways. It's a constant measurement, not once a day, but 5-6 times a day you're doing this.
I actually heard an interesting number that it's 300 plus decisions a day that impact your diabetes. So I don't know if that sounds or feels more like what you experience, but that's more aligned with my experience.
Well, that's an interesting way to put it. So like when I say 5-7 times a day, I'm thinking about like major meals, snacks. Those are all decision points. But actually back in 2007 when Twitter started, I tweeted my blood sugar for a day. And I didn't just tweet, "Hey, here's my blood sugar." What I decided I would do is every decision point I would tweet about, like, "Oh, I want a cookie, but I can't have one." Or, "Oh, I'm going to go for a walk, but I'm having a low blood sugar." So I think it ended up being about 177.
Yeah, that sounds about right. And so that's exactly the point of OpenAPS is it takes some of the mental math out of the picture. And it says you're doing this math over and over again. And if you're paying attention, great. But if you want to focus on work or you want to watch a football game or you want to sleep, that's not something you want to do constantly throughout the day. So the point of OpenAPS is it takes the data, it interoperates between medical devices that were previously incompatible and you couldn't talk to each other, does that math, and then actually sends the decision and enacts a command into the system, reads the data back, and does it over and over again. We humans get tired of those hundreds of decisions a day, and that's why you start to stop making as many decisions if you have a bad day or you're tired or you're sick. But the system, when it runs, just keeps going every 5 minutes or every 3 minutes, however you program it. It's going to keep reading the data, making a decision, reading the data, making a decision.
Mm-hmm. Yeah, one of the things that's absolutely repeated when you talk to diabetics is there's this fatigue, there's this decision fatigue. And some people hit it 20, 30 years into their diabetes, and some people hit it a few months into it. And I've met a number of folks that have just basically kind of just given up. And like, this is as good as it's going to get for my blood sugar. I'm just so tired every single day. I just want one day off. Does this give you a day off?
It doesn't give me a day off. I mean, with the system, and I'd love to explain to people exactly what it is, because people probably have some question marks over their head.
Of course.
But to answer your question first, it's still work. I still wear an insulin pump. I still wear a continuous glucose monitor. I still test my blood sugar with finger sticks multiple times a day. I still count the carbs and what I eat to figure out what my meal dose is. But this fills in the gaps. It softens the edges on any human errors that I might make. And it kind of rounds off the errors of life and the things that affect your blood sugar, which is really amazing. So, I was explaining to somebody yesterday that it's still work. It's not a cure. I still have diabetes, but it's less work and less burden and causes less fatigue than if I didn't have the system at all.
Mm-hmm. Okay, so let me do my analogy, and we'll go from there, and you can explain exactly how this works and how you've closed the loop. I always use the analogy of an airplane flying from one side of the country to the other. And in a world of finger sticks, where you check your blood sugar with a finger stick, and manual injections, the finger stick is like checking your altitude, and the injection is adjusting your altitude with the stick. And you only get to check your fingers, your altitude, 5 or 10 times, and you only get to give yourself manual injections 5 or 10 times. So wouldn't that be a jerky flight from LA to New York as you're going, and you're adjusting your altitude? With continuous glucose meters like the one that we both wear, I'm getting hundreds of data values. And with a pump, I can make little tiny adjustments. So it's really an issue of resolution, isn't it?
Mm-hmm, exactly. And that's the thing, is that CGM and pumps are better than finger sticks and, manual injections for a lot of people. A lot of people choose to wear these devices, but you still have to constantly check between what is device A doing and what is device B doing. And if you choose to get these devices from different manufacturers, it's even harder to go between the two devices and, again, do that mental calculation in your head about what needs to be done. And that's where, not paying attention or fatigue starts to come into play. And it's more easy for somebody to not do the really precise mathematical calculation and round up or down based on what's easiest for what they're doing at that moment.
Right. And even a little bit of not paying attention, just as in an airplane, you can find yourself off course. A real world example, just literally an hour ago before I got on the phone with you, I noticed that my blood sugar, I'm looking at my CGM right here, it had just slowly, ever so slowly over a period of 2 hours, creeped up. Mm-hmm. And it's not bad right now, but it's not great. And it just happened because for 2 hours, I didn't look at my meter. That's an example of like, oh, wow, wait, I'm 3,000 feet higher than I should be. Where's the mountain I've lost? And then suddenly I have to make a correction, and now I'm on a roller coaster bouncing up and down in my altitude.
Yeah.
Smoothing that out would be wonderful.
Well, the other thing that's challenging, that I don't think a lot of people understand, is that you're constantly playing catch up because the insulin doesn't work immediately. You might give yourself a dose to adjust to the number, but that insulin, depending on your body and the type of insulin, may not peak in your body for 60 minutes to beyond that. So you have to make a decision looking ahead that says, what am I right now? Where is my trend heading? Am I going up or down? What am I going to be doing in an hour? Because, for example, if I'm going to go for a run in an hour, maybe I don't want to correct if I'm slowly rising. I want to be a little bit higher. But if I'm getting ready to go eat, wow, I need that insulin now so that when I go into the meal, I'm in a better place than I am right now. And you don't always know what you're going to be doing. And you don't know, if you're on finger sticks, which way your blood sugar is heading. And that's kind of the challenge. Is it's a lot of snap in time decision making, but it's also you're trying to prepare for 1 hour ahead or 3 hours ahead. And sometimes that's impossible. And you just have to do the best you can. But it's really frustrating.
So applying your very important point about lag, taking insulin and having it take a while, or looking at your blood sugar and having it not reflect reality, applying that to the analogy around an airplane, when I look at the altimeter, it's really not now. It's 15, 20 minutes ago. And when I suddenly go, oh no, pull up, or push down, and I pull on the stick to adjust my altitude, nothing happens for an hour.
Exactly.
So now have a smooth flight, and suddenly you see it gets a lot more. It's like, controlling a Mars lander. It's like you move the joystick and you wait 8 minutes for the thing to do anything.
Right. All while, again, trying to live your life, doing whatever it is you do, making a living, enjoying yourself. So it's not like people want to constantly be doing this decision making. Mm-hmm. It's not like the flight where you get on the plane and you're going to fly from point A to point B. Life, it's day in and day out. It's every single day over and over again. There's not that start and stop point. You don't turn diabetes off. And I think that's the big frustration is people just want a break. They want a day off, but it's a 24/7, 365 constant flight adjustment.
Now, why is it that people who, what I call the normal sugared, why do the normals hear about these things and they go, well, why don't you just do this? And why didn't you just do that? It seems like the word just always gets applied to diabetes. Like, surely they've solved this by now. Or they see that you're wearing a pump and they go, oh, well, it just takes care of it for you. It seems to be like a way of coping with the fact that it really isn't easy, but they really want it to be.
Yeah, and I'm laughing here, thinking back to an experience most people with diabetes have when they meet somebody new, a new friend, somebody who becomes their significant other. Everybody's like, oh, well, doesn't device A talk to device B? Well, of course, my iPhone talks to my computer. I can get my data off my camera onto my computer. Or this idea of interoperability, healthcare and medical devices in particular are very behind. It's very different than anything else that you can imagine. So for somebody who doesn't work in healthcare and doesn't have somebody they know with a chronic illness, diabetes or otherwise, it's very hard to fathom until they get some of these insights and kind of see some of the data and hear some of the stories. So as we talk about OpenAPS, that's one of the reasons I'm very avid about sharing my experience, because it helps people start to understand what are the true challenges of living with something like this. Why are we spending thousands of hours trying to solve this problem? It's because, well, it's not just that easy for anybody. It requires a lot of work and a lot of effort. And until we have a cure, we've got to do better. And I believe that we're not moving fast enough in terms of the healthcare industry, and we've got to fill that gap. So that's what we're doing. But I imagine we'll still hear a lot of responses to this podcast of, oh, well, what about XYZ? Why don't you just do this? And the other point I'd like to make is that for every single person with diabetes, their diabetes may vary. It's different, based on, their body, their health, what they talk about with their doctor, their lifestyle, and what they decide is important. That whole thing will help them figure out what they need to do. There's no one right thing for everybody. What works for me doesn't work for you, Scott. What works for you doesn't work for, the other person we know with type 1 diabetes or type 2 diabetes. Everybody's really, really different. And so that's one of the things I think is cool is we're working to build options so that if you have, pump A and CGMB, you can make these things work together. But if you have different devices, or maybe you don't choose to have a pump, maybe you like multiple daily injections, that you could find something to learn from this technology use that applies to you and helps you. And I think that's one of the cool things we're starting to see is this respect for everybody's individual choices, but taking what we can learn from each other's experiences and this different pieces of technology and just gain a better understanding of diabetes and how it works for each of us.
This episode of Hansel Minutes is brought to you by Braintree, code for easy online payments. If you're building a mobile app and you're searching for a simple payment solution, check out Braintree. The Braintree V.0 SDK makes it easy to offer multiple mobile payment types, so you can start accepting PayPal, Apple Pay, Bitcoin, Venmo, credit cards, and more, all with a single integration. One small snippet of code and you're set up in less than 10 minutes. If you don't have time, you can give them a call. They'll even handle the integration for you and walk you through it. The SDK supports 7 languages: .NET, Node, Java, Perl, PHP, Python, and Ruby, elegant code, clear documentation. To learn more and for your first $50,000 in transactions fee-free, go to braintreepayments.com/Hanselman. That's braintreepayments.com/Hanselman. Okay, so let's take an inventory of the things that you need and what we talk about the closed loop. Let's talk about this loop. So you need a monitor, something to tell you what your blood sugar is now, and you need a delivery thing. So you talked about pumps, which deliver. Pumps don't usually look at your blood sugar. They deliver. They're the right solution, right, WRITE, while a CGM, a continuous glucose meter, is the read. And we tend to have ones with different brands, right? Like mine are a different brand. Yours are also?
Yes, different brands.
So totally different companies that don't presumably talk to each other. There's no standard. Like I can go to my car, plug my Bluetooth in, and hey, look, it works. They never talk to each other. There is not yet a standard for that kind of stuff. It's coming someday, but we're like you said, we're years behind. So you have these two devices. Where's the loop here? How do you decide? Like you look at one and you think and you make a decision and then you push a button on the other?
Yeah. So historically, for those without diabetes, what you would do is you would either do a finger stick or look at your continuous glucose monitor and see what your blood sugar is. And then again, do this decision based on your body, your ratios, and say, I need more insulin, I need less insulin, I need to eat. If it applies to insulin, I need more or less, you would look at your pump and say, okay, I'm going to put this into my pump, more insulin, less insulin, it would deliver. Again, with the lag time, you wouldn't see it go into impact immediately, but then 60 minutes later, you would look at your blood sugar again and say, okay, more or less, etc. But again, your body, your brain is that decision maker and that button pusher. So with a closed loop, what we're talking about is some kind of computer system that will read the data from the CGM, do some kind of calculation that your brain normally would do, and then send a command to the pump. Now, ideally, this would be an all-in-one single system. That is coming on the market, and we can talk about what commercial options look like. But the key point here, it's not available today. It was not available 2 years ago, 10 years ago, when a lot of us wanted it. So we started figuring out, if we could get the data off the device, which again was a struggle many, many years ago. But as of 2 or 3 years ago with Night Scout, Dexcom Share, MiniMed Connect, that's becoming easier to get the data off the CGM so that you can get a quicker real-time view of your glucose data. Because we can get the data off more easily, you're able to add other data to it, like what is the pump doing? What are you eating? And as a result of all this data, you can actually basically build a prediction engine that says, because this is the trend, this is what your altitude is, because of the weather conditions, because of all the things going on, we expect that the plane is going to lower, or your blood sugar is going to lower. And as a result, we need to adjust by giving you less insulin to help you blood sugar level off, the plane level off. And so that's exactly what the system is doing. Now, in terms of what is that piece of hardware, again, we don't have an all-in-one system. And as of a week ago, I would have told you there's one working solution. But as of this week, we've actually got 3 different hardware options that'll work. But the point is you need a small computer and you need something that will talk to the device. The first setup option that we made work over a year ago is a Raspberry Pi, which is a small mini computer that a lot of people listening to this podcast are probably familiar with. And that kind of became the brain of the system. And the other thing we used for the longest time is a CareLink USB stick, which is actually made by the pump manufacturer to read data off the pump. But we found there was a little security hole that everybody freaked out about years ago. There's this big cybersecurity scare of, oh no, somebody, if they had your serial number of your pump, they had this CareLink stick, and they were within 3 feet of you, they could push insulin to your pump without you knowing it.
I remember that.
Yes. And so everybody freaked out. The FDA decided that Medtronic needed to change that. And so Medtronic would swap out the firmware as pumps came back, and all future pumps did not have this feature enabled. So that's why you'll hear us talking about older generation Medtronic pumps for this system that still have this security option enabled.
So to put this in layman's terms, is this kind of like rooting your iPhone and then they came up with a newer version and now you can't root it?
Exactly.
Okay. So then to give the pump a command to say, give me this much insulin, I need an older one that doesn't have that I'm actually using the security hole.
Exactly.
So I just got a new pump last week because mine was out of warranty. I have version 3. You have an older one, and you'll have to stay on that one forever until there's a standard for delivering insulin.
Have to? No, but we'll choose to in order to work with OpenAPS. Absolutely. So okay. I too have a more modern pump that does not have this feature enabled. That was my in-warranty pump, and I stopped using it about a year and a half ago because I found one that worked with this closed-loop system. Mm-hmm. And I want to talk a little bit more about the security of this before we talk about the hardware, because a lot of people say, oh gosh, I would never, why are you doing that? That's so insecure, et cetera, et cetera. And this is where we get to talk about the limitations of the physical hardware system. Like I mentioned, you have to have the exact serial number of the pump. It's actually kind of hard to get because the pump is attached to your body with pump tubing. And most people have a clip over the back, and the serial number is hidden on the back under the clip. So you would have to be a very good friend or family member of somebody to get a hold of their pump without them noticing it, get the serial number, plug it into a system, build it, be able to test it without them knowing, and be able to issue a command. The pump has a bunch of hardware safety things built in that are really great. Like when you do insulin delivery, it'll buzz or beep based on your settings. So if somebody did something to your pump without you noticing it, you would get a buzz or a beep. Additionally, you have the backup feature of tracking your blood sugar. So if you suddenly started dropping, you would check your pump and say, what did I do an hour ago that's making me drop now? And you would look and say, I don't remember that. Usually it's because you did something in your sleep. Like you woke up, gave yourself a bolus because you thought it was a good idea at the time, and you go back to sleep. But in the rare case that somebody was maliciously trying to deliver insulin to you, there's a lot of work and effort and a lot of free coincidences that would have to happen for it to work.
Well, and it also has a maximum amount that it'll give you in a certain period of time.
Exactly.
And it's a dangerous amount, but it's not like deathly dangerous. And you can set it yourself. Like 10 units is an amount of insulin that my pump is set to be the max. It would give me a bad day, but it wouldn't kill me.
Right. And that's
and I'd notice it.
Right. And you would probably notice it before it got to a very severe point.
And I'd likely feel it going in as well. That's a lot of insulin.
And again, the beeping. And you would have to notice somebody within 3 feet of you with this device.
Right. And you can't exactly pickpocket something when it literally has a 2-foot cord attached to your body. It hurts.
Yeah. And so I just want to kind of set that out of the way. So as we move forward talking about OpenAPS, say, yes, we are using this kind of quote security hack, but it's not what people think when they hear that we quote hacked the pump.
So that's a really, really great point. You're using the pump and the features that it had available to it. There's no maliciousness. It's a hack for good at best. But wouldn't that then imply that the company that makes the pump and the companies that make the CGM could have done what you all have done themselves, but maybe haven't chose to because of either regulations or potential fear of being sued?
Yeah. So the companies that we're talking about are working on closed loop systems. But because they are big traditional institutions, because they are working through traditional clinical trials and regulatory pathways, they are working on a closed loop system, but it's not going to come to market until 2017 at the earliest. And that's the whole point with OpenAPS is there are closed loops coming, but because we have the technology available and we have the community of people who've helped us figure out how to do this and how to make it better and better in terms of hardware and software, because we believe we can do it safely, we don't think there's a reason for us individually to choose to wait. If we want the system, we can build it and do it. And that's kind of the core of OpenAPS. It's about, there's this reference design, there's this implementation that's open source. We're not forcing it on anybody, but it's if you want to build it yourself, if you don't want to wait and you think this would help you, whether it's for overnight or, everyday use, then, it's there for you to build it. The manufacturers have a different approach and process, and it obviously takes a lot more time, to get a system through FDA approval. Our thing is not FDA approved. It likely won't be. But again, it's the open source approach of if you want to use it, you can, and there's a community support. But the reason we emphasize DIY a lot, if you look at the OpenAPS documentation online, you'll see a blog post I wrote that I linked to that's why the DIY is important, because when something breaks, and it will break, you have to know how to fix it, or you have to know that it's broken, and you have to be okay with it. It's not something physically broke off, but it's no longer reading from this device, or it's no longer writing to the pump, or I'm not quite sure what's happening and why. So it's up to you as the individual using the system to be able to troubleshoot and put the pieces back together or get back in range of the device, or whatever it is that you need to do. But because of all this, the OpenAPS design is actually designed for failure. We don't do boluses, which is like a big burst of insulin like we've talked about. We only do micro adjustments called temp basal rates.
I see. Okay, so you're not taking care of lunch for me.
Right.
You're taking care of, like the example that I gave at the very beginning where I wasn't paying attention for 2 hours and my altitude, my blood sugar slowly creeped up to the point where it was actionable. Would that be like... is a good analogy saying my car was kind of slowly creeping out of its lane on the freeway, and if someone were just watching the lines, they could have kept me in the Like, it's not a self-driving car, but it certainly would be nice to just automatically stay in the lanes.
Well, I would think about it, yeah, or you could also think about it more about speed. Like, you really want to maintain 60 miles per hour or 30 miles per hour. Yeah, it's more like cruise control of, wow, your foot came off the gas, you started slowing down, we need to speed you back up. Or you're going too fast, we need to tap on the brakes gently, not a full stop, but let's just slow you down incrementally. And that
is a great analogy, because that's very clear. Like, we all know what adaptive cruise control is, right? Mm-hmm. It keeps distance between the car and the car in front of you, but it is not a self-driving car.
Right. And that's exactly what this does, because if your blood sugar rises slowly, like your example, you need a little bit more insulin over time. And if your blood sugar slowly drops and you're not paying attention, you need less insulin. And so that's what the system does, is it says you have these pre-programmed basal rates on your pump. Let's say an average might be 1 unit per day in the morning. Now in the afternoon,
1 unit per hour.
1 unit per hour.
Yeah.
Starting in the morning. In the afternoon, it might be 1.3. And then in the evening before you go to bed, it might drop to 0.8 units per hour. Mm-hmm. So
just little micro adjustments.
Right. Based on your body, your schedule, and what you know works. But on Monday, you go to the gym in the afternoon, whereas Tuesday you don't. So on Monday, you might need less insulin. So most people will manually start hours ahead saying, I'm going to the gym, I'm going to eat my snack, do my protein shake, reduce my insulin, yada, yada, yada. All these different tweaks in order to have good or better blood sugars or better reaction to that experience. But you can't, it's really hard to constantly change your basal rate throughout the day if you're manually doing this. You can do it, but just like everything else, it's really exhausting. So the point of this,
people forget, right? It's like putting your phone on. I'm just trying to give the analogies for people who are normal people it's like putting your phone on silent, you know?
Yeah.
And then one day you don't, and then your phone goes off in church or whatever. Like, it's just, at some point you just get tired, and it's exhausting. And the thing that's so bad about diabetes is that, you know, people will ask you or I, how are we doing? And we don't know. I'll let you know when we're 60 and we're not dead.
Well, the other analogy that I think about that I think people could relate to is this idea of geolocation. Like, wouldn't it be great if when you got to work or when you left work, your phone noticed that you left work and sent a text to your spouse that said, I'm on my way home. I'll be home in 20 minutes. Mm-hmm. And the spouse or partner who needed to know it for whatever reason could put dinner in or take dinner out or get the kids ready or whatever it is that you needed to do. That's the same idea of this system. Is we started to notice a change in your location of blood sugar. So you walked out the door, your blood sugar started dropping. We don't know if you walked for coffee or you got in the car to come home. But we're gonna change something as a result. And if we need to, we'll change back. If you go back into the building and you go back to work because you just went for coffee for 5 minutes, no big deal. But if we know you end up getting more than 3 blocks away, that probably means you're going home. So we'll send the text. And the same thing with the system is if you have one data point that's really extreme, it will react and respond with a high temp or a low temp, as we call it. But if it then resumes back, wow, that was just a really fluky data point because just for whatever reason, you had this one weird data point. We're not relying on that single data point. We're relying on an average and the deviation.
On the trend line.
On the trend line, exactly. And we can respond to that. But if you really did go straight up or straight down, it is the safest thing to do to respond to that. Mm-hmm. So the system is taking into account all of these things. But what I was talking about in terms of designing for failure, because we've got these temporary basal rates, we have them enacted for 30 minutes at a time, which means if you walk out of range of system the minute that the command is issued, it's going to be the safest possible thing to do for 30 minutes based on the data available. And at the end of that, if you're still out of range of the system, it reverts back to your standard basal rates, this pre-programmed insulin. So when we talk about, okay, what happens if it fails? What happens if it breaks? If you go out of range, it goes back to what we call, quote, standard of care, which is your pump just continues issuing the insulin. It's not the greatest setup. We would love to have it auto reading all the time. But for the average person walking around without a closed loop system, that's what they do every day. The pump, regardless of the situation, especially overnight, regardless of what your blood sugar is, it issues that standard pre-programmed insulin rate. And what our system does is if it's in range, it reads, it says you need more or less. It enacts, it reads back that happened, adjusted the data, reads again, and does it over and over and over again. Mm-hmm. But again, if you walk away from it, something breaks for whatever reason, it's okay. It reverts back to the standard. It's not like we're taking basic insulin away from you.
One of the things that I like about the open source approach and about the OpenAPS approach versus whatever the big corporations will do is while they're all well-meaning, while there are often diabetics involved, here you've got diabetics building software for diabetics, which really gets to this idea of user-centered design, right? You're building in features that matter to you because you're wearing the thing 24 hours a day. Like, you're living this. Of course, it's going to be what you want. Well, who knows if the thing that you said might come out in 2017 is going to be what we want, or if it'll be a shadow of what we want.
Yeah, and that's something that's interesting to me, because when we first, quote, close the loop, I did it for myself, based off of a previous kind of alert and algorithm system I had built that was manual. It gave me an alert and said, you need to take action. We recommend this much. But I, as a human, would press the button. What we basically did is use this physical hardware setup to close the loop and communicate between the devices to create this closed loop. So it was easier than we thought it would be to actually close the loop, because we had been building and testing this recommendation engine for about a year. Mm-hmm. But everybody said, well, you're N of one. It's just you. How do we know it's going to work for anybody else? And we said, well, maybe it won't, but we believe it will help other people. And we want to find a way to make it open source and find a way so that somebody else who wants to build their own doesn't have to spend 2 years building the system like we did. And so that's how it became OpenAPS, in this open source movement around, we can't give it to you because of FDA regulations of distributing Class 3 medical devices.
You're not selling these.
We're not
you're
selling.
Not
we're not distributing.
Setting them up.
But the reference design is online at openaps.org. There is documentation on GitHub. There is code available for you to review and potentially implement based on GitHub. And we did that because we wanted people to be able to do that. And what's been really cool is seeing in the past calendar year, we have gone from one person to now 30 people using the system and using it overnight. And it's not just adults, it's also kids, parents who built it for their kids. We have 17 adults, I believe, and 12 kids using the system. And it's pretty amazing that it works for people of all ages, all sizes, all lengths of times of experience with diabetes.
So in the remaining minute or two that we've got in the podcast here, let's look forward in the future a little bit, because you've built effectively a bridge between APIs. Like, this is very interesting for people who might be listening who may have built bridges between APIs, except that what's so interesting about this is we have these bridges to APIs that are our own bodies, right? We are affecting ourselves. Like, you have a personal area network effectively where you have an API to get your blood sugar and an API to deliver insulin. But we also have things like Fitbits, and you mentioned geolocation. I've got a Microsoft Band. I did a demo at Build where I integrated those. Is it possible that we could do things like, oh, she's going for a run. I'll go into going for a run mode because I can see that from this personal area network that she's wearing. Yes.
And the thing that I get asked the most is, what about a heart rate monitor? People are very interested in incorporating heart rate monitors, but all these features are possible. Absolutely possible. You leave the school, it's time for PE, your system needs to do XYZ. So some of that predictive, alerts versus just reactive. So that's definitely in the future. It's definitely possible. And as more people come on board, it'll be interesting to see what happens. And I think the other cool thing is thinking about how this open source community is going to affect the manufacturers and the traditional products that'll come to market. I think we're learning some important things about how people use these systems, what things are important. Like, it's okay for the user to do meal bolus. The system does good enough picking up and rounding the edges of the user error. What's more important is XYZ, and that kind of thing. And I think that's what's really neat about this project, is because we are kind of closing the gap and bridging also between the stakeholders. So the traditional manufacturers who are doing clinical trials with devices, as well as the FDA, and bringing that user-centered design approach to say, we've got a system that is basic, safe, and effective, and more so than standard of care. How is your system going to compare to that? And what do we need to do to make your thing better so that when it does come out and people do want an all-in-one device, they can purchase it and understand how it works and use it successfully.
Very cool. So last question, where can people go to get involved to learn about OpenAPS?
Awesome question. OpenAPS.org. That'll link you to our docs. It'll link you to our open source code, and it'll link you to us if you need to get a hold of us and ask any questions.
Very cool. Dana M. Lewis, thanks so much for chatting with me today.
Thank you so much.
This has been another episode of Hansel Minutes, and we'll see you again next week.